percent yield, which is pretty much figuring out how much of a product you get and compare it to the amount that you should have gotten, which is your theoretical yield. As an example, there's a recipe on how to make a 4-ingredient quick double chocolate chip cookies. And so you have the reactants, which are your ingredients: 1 box of cake mix, 2 eggs, half a cup of oil, half a cup of chocolate chips, and your product would be your 24 cookies. So the question would be is, what if it's a percent yield if 8 cookies are made using a 1/4 cup of oil? So a 1/4 cup of oil is pretty much half of a cup of oil. And so if you put things into perspective, that would technically make 12 cookies. But in this situation, you have 8. So you would go off and try and figure out what percentage did you end up with, which is called your percent yield. Okay, so you have a worksheet that looks just like this one. It's your percent yield worksheet. Make sure it goes on page 19 of your ISN, and you can go ahead and put the work directly on your ISN. Okay, so it reads, what is the percent yield of ammonia if 40.5 grams of ammonia are produced from 40.4 grams of hydrogen? Okay, so the first thing I'm going to tell you is on this one, it's going to be a mass-to-mass problem. So you have 2 numerical values, and you're going to have to figure out which one is your given. To do that, always think that your given is going to be whatever number has any of the compounds that are in your reactant side. So just for the record, okay, these are your reactants, which are on the left side of the arrow, and this would be your product. Okay, so we find out that 40.4 grams of hydrogen, well, hydrogen is your reactant side, so that's the one that's going to start as your given. I know you guys thought it was kind of funny that I'm doing this at the same time, but try holding a phone and drawing this. It's not the easiest thing in the world. Okay, so you have 40.4 grams of hydrogen, just like that. And I want you to go ahead and write it onto your paper. Make sure you draw all your little boxes. Okay, so it's a mass to mass. And so if we have grams here, that means that this next step is going to be moles and grams. Make sure that your unit and your compound are diagonally the same. So it's grams of H2. And we have 1 mole of hydrogen here. Okay, so the molar mass for hydrogen at 1.01 times 2, it's going to be 2.02. Okay, so that allows us to cancel grams with grams. And now the next step is going to be that using moles over moles. Just like this. Go ahead and write it down. And so this should be diagonally the same. So hydrogen would go here. And the other compound is going to be the one that is being questioned. In other words, the product. So in this case, it's ammonia. Okay, so ammonia has a coefficient of 2. So we put that coefficient. We write NH3. And then our coefficient for H2 is going to be 3. Okay, so that allows us to cancel moles with moles of H2. Okay, so if our step was moles over moles, that means that this step is going to be grams and moles. So we want this to be diagonally the same. So we're going to write moles of NH3. Okay, and that's going to be 1. And this is going to be grams of NH3. Okay, remember you need to have the molar mass of NH3. So In this case, it's 17.04 grams. Just like that. Okay, so that allows us to cancel moles of ammonia with moles of ammonia, and so we're left with grams of ammonia. We're going to go ahead and we're going to multiply across. So 40.4 times 1 times 2 times 17.04, that's going to give us a large number. It's going to give us 1,376.83. And then we multiply the bottom numbers, 2.02 times 3 times 1, and that's going to give us 6.06. Okay, so you multiply the top and the bottom, and that comes out to 227.20 grams of NH3. Okay, so what this is telling us is that if we started using 40.4 grams of hydrogen, theoretically or technically, this is how much of ammonia we should get at the end of the reaction. But what this is telling us is that when we did it, this is how much we got. So as you can see, we didn't get the amount we should have gotten. We got significantly less. But to do the percent yield, don't forget that percent yield is going to be, and I'm just writing it down. You don't have to write this down other than having it in your notes. So it's going to be the actual yield over the theoretical yield times 100. Okay, so our actual yield, how much we actually got out of it, is going to be, like we said, 40.5 grams of ammonia. Remember, we're still talking about that product. That's always that's always going to be the one that we're going to use in this part of the problem. So our actual yield is, like I said, 40.5 grams of ammonia. And our theoretical, which is what we should have gotten, is 227.20 grams of ammonia. Okay, and because this is a percentage, it's going to be times 100. Okay, once we multiply those, we're going to get a grand total of 17.83%. Okay, and that's our answer, and we're done. That's all you have to do. The only thing that I think that you're going to have problems with is trying to figure out which number do I use first. And like I said before, if you focus on which ones are reactants and which ones are products, remember that you're always going to start, or your given is always going to be whatever your reactants are. So in this case, on this side, it's H2O. So whatever number H2O is attached to, that's the number you want to start off with. Like this one says 12.3 grams of O2. We don't want to use that as our given. That's what we're going to use when we calculate the percent yield. So we keep going, and this says 14 grams of H2O. So we would start with 14 grams of H2O in this step. Okay, and then the 12.3 grams of O2, that would represent our actual yield. So it would go here. So that would be for number 2. And then if you go on for number 3, it says 107 grams of oxygen. Oxygen is over here on the side of the products. And again, we don't want to start with the one on the product. We want to start with anything that's in the reactants. So we skip that because that's going to go again in the actual yield. But this one says 300 grams of potassium chloride. So that's going to be where we start. Okay, and as you keep going, just make sure that you're using, as you're given, any of the numbers that are on the side of the reactants, not the side of the products. So in this case, this talks about 167.55 grams of iron, which is on this side. So yes, that would be good to start with this one. And this one would be your actual yield, which is a 220 grams of iron sulfide, which is on the product side. Okay, that's pretty much it on this one.